It may look like a machine is simply unloading a ship, but inside the system, thousands of particles are being carried by air at remarkable speed. No belts, no screws, no buckets, just air, pressure, and controlled flow. This is pneumatic conveying, and it is one of the most important ways industries move powders and granular materials safely, cleanly, and efficiently. But how can air move materials like cement, grain, plastic pellets, or minerals through a pipeline? And why doesn't the pipe simply block? In this series, we break down the technology behind large-scale industrial systems. We'll explain how they work, why they matter, and the engineering challenges behind them. Welcome to Explained. Pneumatic conveying is the movement of bulk materials through a pipeline using air or another gas. Instead of carrying material on a belt, the system uses airflow to transport particles from one point to another. This makes it useful in places where materials need to stay enclosed, controlled, and protected. And when properly designed, pneumatic conveying keeps the process dust-free. The process starts when the material enters the pneumatic conveying system from a storage or unloading point. From there, air takes over. What happens next depends on how the system controls the air. In a pressure system, air pushes the material forward through the pipeline. In a vacuum system, air pulls the material toward its destination. Simple in theory, but inside the pipe, the flow is anything but simple, because powders and particles do not always behave the way we expect. Some flow easily, others stick together, create dust, absorb moisture, or wear down equipment from the inside. A small change in speed, pressure, or material flow can be the difference between smooth transport and a blocked pipeline. That means the system has to be designed around the material. There are two common ways pneumatic conveying works. In dilute phase conveying, particles are suspended in fast-moving air. They travel through the pipe almost like dust in the wind. In dense phase conveying, the material moves more slowly in concentrated waves or plugs. In both methods, the key is keeping the material moving at the right speed. Too little airflow, and the material can settle inside the pipe. That can lead to blockages. Too much airflow, and the system can waste energy, damage the product, or wear out the pipeline faster. At the end of the line, the material is separated from the air using a filter, cyclone, or receiving vessel. The air is removed, and the material continues to the next step in the process. So pneumatic conveying is not just air pushing powder through a pipe. It is a controlled balance of pressure, velocity, material behavior, and precision engineering.